So what we're going to do is enter this program, different package name, doesn't matter, and we're going to set a breakpoint on it so that we can watch the values change. We can watch the variables change. And so my question is going to be, without adding a print statement to this code, because that's too easy. That would take like just seconds rather than, minutes. So we don't want that. What are the values of y and r? When x is 4. Now, I'm kind of introducing this for two reasons. Have we already done random numbers in here? All right. What a random number generator is it's a algorithm which will generate an unpredictable number, at least unpredictable to us, based on a mathematical algorithm. And depending on its seed value, it'll generate a different series of, quote, random numbers each time. Now, if you give it the same seed value, it generates the same series of random numbers every time, which wouldn't be very fun. Like if you're going to play Yahtzee and you got the same numbers, same sequence of numbers, you'd eventually figure out pretty quick how to win the game. So you shouldn't seed it with, a fixed number in a program. You should instead seed it with, the number of milliseconds past midnight or some unpredictable number like that. And you use random numbers in games, among other things. And among other things like testing sort algorithms and stuff like that. Because when you roll a die, you're rolling 2 dice, you're generating 2 random numbers. So if you wanted to, or if you were, simulating a card game, you'd want to be able to generate random numbers that would pick which cards you had. So that's not the real point of this, but we're going to modify this so that it's actually not a bad random number generator program, because it is right now. It generates the same random number every time. So the point of this exercise to begin with is going to be setting the breakpoint and stepping through it. I want to find out what r becomes when x is 4. So what I'm going to do is I'm going to set a breakpoint right here. Hello? And then I'm going to run it in debug mode. The way you do that, well, there's a debug menu up there. Debug project or debug file will do equally well. And what that does, and I'm sorry that it covers up some of the code so that you can't see all the code, is it runs it to the point of the breakpoint, but then it breaks the program. It stops running right there. And then each time, and then you have these 4 buttons that become active up in the toolbar. You can continue, which would just run the rest of the program. You can do step over, which means step to the next line. Or you could do step into, which is, a couple over. Step into would let you, if you were calling a function. So I'm going to demonstrate step over. Step over, and now I can see what the value of r was. I moved my cursor over here, and it says r is 13. So it generated a random number, pseudo-random number, and the first random number was 13. I can also see that up here. I'm going to keep stepping over. It's going to go into this for loop. So it's going to calculate a value of y, and it's going to use that value of y to generate its next random number. So now that it's done that, Well, my question is not going to be quite answerable. But you can tell me what r is equal to when x is equal to 4 by stepping through it. You can watch it. Right now x is equal to 0 and r wound up being 92 or 32 or whatever that is. But you keep doing the step over thing, and now we have a new value of r. R now equals 18 when x is equal to 1. And so on. You see what it's doing? That green line indicates where our current position is, and we're executing line by line so that we can watch the values of the variables change. Now I'm going to stop the debugging so that y'all who haven't finished typing this in can do so. But for those who did, I'm going to come around and watch y'all run the debugger to find the answer of what r is when x, what r becomes when x is equal to 4. The way you set a breakpoint is to click on the line number. So y'all can come in late, just make a new project, enter this code. You'll have to add an import. Well, it's up there. Import java.util.random so we can use the random class. That could very well be. I'm going to have to watch somebody else. I didn't run it far enough to find out.
Oh.
Step past this one so that it actually executes it. And it becomes step past this one so that it actually executes past these values.
Did that turn a little random?
Run it a couple more statements. Step over again, step over again. All right, and then y becomes, well, we're getting different values here. But that's okay. Maybe it's not going to be the same. Do it a second time and see if you get the same answer. Okay, you two got the same answer this time. I think.
Well, now you debugging QN.
To stop debugging, you press the
Oh,
kill button, and then you can start it again. So we have a few errors. Put your cursor over that. Right, it's already Let's right click on that package that says random. Or better yet, right click on this node right here. And
Right
enter
now I'm
the factor and
running
call
the
something
debugger
else.
breakpoint to see.
I think it's going to be
Um,
Oh, my
double
bad.
click,
Oh, wait.
right, one of the numbers to set a breakpoint. You go to debug and stop that one, not remove. Alright, debug, debug
Change this
project,
back to what
and it hits that
was.
line when it stops. And then, once you have that, it'll, you have these buttons which are available. This one steps over.
That's the one.
No problem.
There we go. There we
That
go.
way you can keep running, yeah. I got the same value this second time.
Okay. What'd you get? You run it, and you click past that statement, it becomes 77.
So I got.
But then it becomes 27.
Yeah.
When did it happen? Okay. Y'all are all getting the same answers.
Okay, good.
I also want y'all to try actually stepping in to this function right here. The way you do that, you could just set a breakpoint in it, but instead, use the step into instead of the step over when it gets to that line. So as soon as that R is equal to R and DY line is highlighted, you step into rather than step over, and you'll see it step into this function. I will demonstrate that, much to the distress of the people still typing this in. So I chose debug file, that's my current line. Step over, step over, step over. Now I'm on the line that I want to find out more about what it's doing. So I'm going to move over a few clicks and find step into. It's 2 over from the step over. And that puts me inside the R&D function. And I can still watch the variables. Notice you have different variables up here now because you're in a different function. Those old ones are in a different scope, so we can't see them anymore. And it created a variable called num, and we got one called 92. If we want to return out of it, we can use that 4th button, step out, or we can just continue to step over, and once we hit the return, we're back out of it. That is invaluable for debugging. It's like I ought to teach 2 or 3 classes just on debugging. Once you become a professional programmer, you're going to start using debuggers like this in order.
Through it, Y flashes in and out, even staying within the same method. See Y is here. Watch when it's-
That's because Y is defined here, and as soon as it hits the brace, it momentarily falls out of scope because this is being reevaluated.
Okay.
If we move the int Y, and I showed that up above it, yeah, that would be better.
No, it won't. It'll
Right,
stay in-
right. That's a very good point. When you're watching it, Y is going to disappear and reappear each time it completes a for loop. And the reason why is it's because it's declared in the for loop itself. If you don't want to do that, you could change it like this. And then you'll be able to see Y the whole time. Because it's no longer being declared and disappearing as soon as it hits that close brace. So if you figure out what what R equals after X becomes 4. Step over, R becomes 92 when X is 0. Let's keep watching it again. Now X is 1, so let's find out what R changes to. Changes to 18. We can also just move the cursor over. So X is currently, R is 18. Keep going like this until you find out what R changes into when X is 4. Figure it out. You got to set a breakpoint first. So you click on the line number that you want it to stop. How about 20?
That should be 4 stop on.
Click on the line number
That's what
itself.
and if you go
That
through it
sets a
one more
breakpoint
time,
where to
it's
stop.
how
You
you
choose to run file.
Yeah.
You
Ready
go
to go?
down there and then you
Yeah,
choose
right,
step
yeah, easy.
over. Then watch what the variables become.
Yeah, no problem. I just figured out I wasn't going through that final time. So,
You scroll down and find, okay, so click step over, click step over expression, do the one plus, do it from there. So now you're on that line, do it again, now you're on that line, do it one more time, and you see what R changed into. When X was 0, R became, yeah, and you can keep doing that to find out what R changes into when X is equal to 4. Why do you use debugging? Sometimes you just can't figure out what's wrong with your program. And you need to be able to step through it line by line. That's actually the fastest way of figuring out the logic of a program. You know, if you're given a complex program, and you're trying to understand the logic of it, just looking at the code usually isn't enough. And maybe you don't have, diagrams showing what the code does. You can just set a breakpoint in it and kind of cruise along inside the program until you get a good feel for it, until you can, kind of build your own internal map of what it's doing, or, you can actually, be writing stuff down. So debugging, very important. It's a very useful skill to master. I wish I could make it stop doing that. All right, I don't remember the last thing we did. I thought we were almost done with this chapter. Go check our notes. String functions and password validation. Okay, so we talked about, nope, that's the wrong
Yeah,
class.
that's not,
This is Python. Wouldn't be a bad thing to do. As a matter of fact, maybe we'll do that. The idea in that lecture in my Python class was to talk about using functions, string processing, in order to count the number of numbers in your password and the number of, uppercase letters and the number of lowercase letters. And you do all that, and then you can decide whether it meets the rules. And unfortunately, every site has different rules. Some require one uppercase letter, some require, no special characters, some of them require one special character, all that kind of stuff. But I do want to remember where we were. Ew. We haven't had any notes since October 13.
I have that we were talking about the built-in math functions.
Okay.
Math.py specifically, and the right justified, left justified
Okay.
stuff.
Have we talked about substring and index of? Okay. So we really are pretty much done, because we've also talked about printf, if I am not incorrect. So we are done with this chapter. But I do want to do the password style program, where you ask for a password and then analyze it to see if it fits the rules. So to do that, we're going to use char@, or maybe just substring, either way, to get out one character at a time, and then we're going to have tallies. The number of uppercase letters, the number of lowercase letters, the number of digits in it, and the number of special characters, and to make sure there are no spaces in it. So let's create our scanner. Let's tell them we want them to type in a password. Please enter a new password. Let's read that into a string. You could just call it password. String password is equal to sc.next. Remember to add the import for your scanner. Then we're going to need a for loop, or a while loop, something. For int I, I'm going to use I as my index counter into the string, is equal to 0. I is less than the length of the string. So password dot length. I++. We want to get that character out so we can examine it. Character ch is equal to password dot getChar. Excuse me, it's called char@. My mistake. Wrong language. All right, now we have that character. For now, let's just print it out. But we'll go back. We're just going to make sure our framework works before we do anything else. Please enter a new password. Hello, $5, whatever. And it printed out hello, but it did not print out $5. And the reason for that is I used .next rather than next line. And so I could either decide that I'm just going to accept that I can't enter spaces, or I'm going to make it say next line. So I went back up here and I changed that to next line. Because when you're entering a password on a web, you can put a space in it, and usually it'll tell you that that's illegal. Even though, wouldn't you be able to make better passwords if you can type an entire sentence in?
Oh, yeah.
You still could, separate it using spaces leave out all the spaces or whatever, but still. All right, now that we have that running, hopefully, I'm probably going to be going a bit too fast. I'll stop in a minute. Let's declare some counters. Int digits is equal to 0, comma, specials is equal to 0, comma, spaces is equal to 0, comma, uppers is equal to 0, and then letters is equal to 0. I guess we could also keep track of the number of lower spaces. So that'll be the last one I add on. Comma, lowers is equal to 0. We'll be able to force them to enter a good password using all that information. Realistically, this should be in a while loop so that they have to type in, a good password before we let them go. So that's the line that I just added. Then we're going to use the character wrapper class to test CH to see which of these conditions it meets. So down here below system.out.println.ch, I'm going to do if character dot is digit CH, then add 1 to our number of digits found. If character dot is alphabetic, we can add 1 to the number of letters. I think that's wrong. I think I should not have done that way. If character dot is letter. That'll do. Okay. So if character dot is letter, our number of letters increases. I'm getting an error there. Oh, because I forgot to pass the letter in. There we go. If character dot is lowercase, then the lowers is plus plus. If character dot is uppercase, now you could calculate the number of uppercase by just subtracting the number of lowercase versus the number of letters, but we have this function, so why not use it? Uppers plus plus. Spaces, we don't need to use the wrapper class character. We can just check to see if that character is a space. If CH is equal to, a single quote followed by a space, that's a single quote followed by a space. I'm not using double quotes because I'm dealing with a character rather than a string. Then spaces plus plus. And the last one I need to figure out how to do is the special characters. There ought to be a is alphanumeric option, and we'll just say if that is equal to false, character dot is letter or digit. Every language calls these things the same thing. But if letter or digit is equal to false, you know that it's a special character. So specials plus plus. Now the next thing I'm going to do, and I don't want to scroll all this code off yet, but for those who are done with this far, put 6 print statements down after the for loop, not the end of the for loop, that says things like digits equals plus digits, like that. One for each counter, but put it after the for loop, not inside the for loop. And then run it. Type in a password. Make it one that you might plausibly use, so you know it has numbers and dollar signs and stuff like that. And just make sure that the counters are correct. This is actually going to count a space as a special character. That's why we have a separate check to see if it's equal to a space.
That's not right here. Oh, yeah, actually that is right. There's only one number in that last bit. Because I.
So then print out the rest of them as well. Print out the number of specials, the number of spaces, the number of uppers, and so on. Just add more print statements.
Yeah.
So add extra print statements, one for each counter. Print out the number of specials, the number of spaces. I only have one up there, but I'm going to go back up there and add the rest. Yeah, uppercase C to lowercase c there. Fix this one with the uppercase. And so underneath all your print statements, let's put some validation code. First thing is, let's make sure it's more than 8 characters long. So if password.length is less than 8, we're going to give them an error message. System.out.println. But length is a function. It's a method, so I forgot to put the parentheses after it. Must be at least 8 characters. And let's do else ifs. The problem with doing else if is that it's not going to show you all the problems with your password. It's only going to tell you one at a time. But hey, that's kind of real life, you know. Yeah. Anyways. But the reason I'm going to do that is so that at the very end I can put a final else that says, hey, it's a great password. So else if, now the rules I'm implementing so far, it's just 2 rules. If digits is equal to 0, I'm going to say Password must contain at least one digit. I don't need to type that whole word. Must include at least one digit. And then one final else. I put some spaces here because I know I'm going to add some additional else ifs in a minute. Else system.out.println good password. When y'all get that far, I'm going to ask you to implement some additional rules. Or am I going to do this so it doesn't cover up the code? I'm going to assume everybody's got this part done. Okay, so my extra rules. Or here's our rules. Password must be 8 or more in length. Must contain at least one digit and one special character and one uppercase letter and one lowercase letter and no spaces. Modify your code to include all this logic. Right now we're only doing the first two, but add the next 4 rules. You got it working? You don't necessarily need to type this part. I just want you to modify your code to meet that.
Okay.
Yeah. So now you're going to come in and you're going to insert extra conditions, more else if statements, to make it match those rules. Okay. So we're going to need to add some more else ifs. We've done it all. With that so low, you can't see my writing. Get the speaker out of the way.
No spaces.
Is and letter, C-E-I-S.
Digits, basically all of those guys. Yeah. You know.
I'll capitalize that L in the word letter. No, I guess it's right. The red arrow went away. Sorry about that. Got it working? So you got your validate logic in there? There you go. Okay, cool. Excellent.
It should have picked it up and it didn't.
That's odd. Okay, it must be.
Oh, it's up.
Okay, yeah.
And I moved one.
When you finally have it working, put this in a while loop. The whole thing, except for the declaration of the scanner. And change your final else to look like this. When you get good password, do a break. Now that's going to show up as an error on mine because I don't have it in a while loop. While I'll do that, I'm going to catch up and meet my own rules. I made these rules go away. Sorry about that. So here's my rules. I'm going to copy paste those into the code so I can follow them myself. I've handled the first two. I need to make sure there's at least one special character. I need to shut ups. So I would use a while true loop. You could do something else. You could modify your code further than what mine does.
That would have been the easiest way.
Pardon me?
That would have been the easiest way.
Yeah, or you make a flag. So to get this to work now, in order to get it to loop, I'm going to go all the way up to the top of my code where it says enter a new password, and I'm just going to put while true. And then I'm going to come down here at the very bottom. That's the end of my while loop. I added another brace down at the bottom. And I made my final else not only do a good password, but to print a break. And I really can't show all that on the screen at one time because this code's 3 or 4 pages long on my screen.
These out.
Okay,
I moved these outside the while.
but you're going to need to reinitialize them to 0 each time.
That's
though.
true.
So you can just copy and paste that line and take the I and T out. Yeah.
All right. Ooh. The infinite loop. What's wrong?
That's probably just one. Unusual scene.
so it's working, but I get an infinite loop if I don't put in a good password.
Whoops. All right, just move this stuff, the
Yeah.
print statement and all of this
Into-
stuff inside the
Okay,
file.
cool, yeah. Infinite loops. Cool mixes.
All right, when you create a while loop, you need a brace, just like you do everywhere else. And then you're gonna need a closing brace down here at the very bottom. This is the end of the while loop. But that was the only problem. I think the rest of this is good. Our indentation's not quite right anymore, but we can fix that. We can highlight all of this stuff.
Okay.
with the tab key. Okay, cool.
Alrighty, I can't really think of anything else to do to this. I mean, we could.
One thing to do would be to put this inside a method. You pass the password to a method, it returns a true or false, whether it's valid or not. And maybe it returns a string giving you an error message to display. Nope, the while, actually, yeah, cut those two lines. Yeah, just cut those both, or you don't have to write the while gone as well, because we're gonna move that way up. The unique, yeah, where it goes is above where we asked them for the password. So all the way to there we go, right underneath that scanner declaration is where our while loop goes.
I'm just supposed to put that less than zero.
No. Because it's only a problem if it's got a space in it. So if the number of spaces is greater than zero, we print an error, hey, don't put any spaces in me.
Alright, so we've used string functions. We've used math functions. I believe we've reviewed them. Math.abs, stuff like that. Let's see what kind of homework we have assigned so far for this stuff. The pH table and the index tags. Okay. I'm comfortable with that being our last homework assignment for homework B, for chapter 5. But that being said, do know how to use the math library. Calculate the absolute value of -5. Calculate 5 to the power of 3. Calculate, pi r squared, How would we do this one, the absolute value of -5? You would do math.abs -5. Calculate 5 to the power of 3. That would be math.pow 5 to the 3. Calculate pi r squared. That would be math.pi, capital letters, times, and you could just say r times r, or you could use math.pow. Either one would be valid. And let's go ahead and put x is equal to in front of all of these, just so that it looks groovier. And the others, substring, char@, index of, will show up in the next quiz, which I need to create tonight. And just remember, I guess I'll put them on the quiz as well. character dot is digit, character dot is uppercase. Character dot is lowercase. I'll post these notes. And also parse double, parse int, parse long, you know, that kind of stuff. So that would be stuff like x is equal to integer dot parse int, where you pass in a string, double dot parse double, where you pass in a string, and so on. And lastly, how to convert a number to a string. Well, we've just been taking advantage of the fact that numbers convert to strings automatically, but you could do it either like this. S is equal to integer dot toString, and then put your number in there. Or you could do this. S is equal to an empty string plus X. And you would change this to double, you know, or byte or long or whatever it needed to be if it wasn't an integer. I like this method just because it's short and sweet. Quiz questions. These are always so silly. What is the name of the class that contains the ABS, minimum, and round functions?
Math.
Yeah, the math class. Integer and character are examples of what?
Wrappers.
Wrapper classes. I like this one. Hover class. I don't even know what that would be. And then the last page here talks about the character classes that we just used. Is digit, is letter, is uppercase, is lowercase. Is letter or digit. Here's one we didn't use. Is white space. We could have used that rather than checking to see if it was a, because what if they entered a tab? You know, we might not want to let them enter a tab. And so on. All right. Onward and upward. Make a Dropbox for these. This will be homework I. Excuse me, in class I. Password. So go ahead and put your password program in there when you're done with it. All right. Object-oriented programming. What did our first exam cover? Chapters 1 through 3, or did it include 4 as well? We're really almost at a point where we ought to not. Oh, I guess we can put this chapter in as well. Because we've been using this stuff already. We just really didn't know what we were doing. Object-oriented programming. In olden days, the standard programming technique was procedural programming. That's because the emphasis was on the procedures or tasks that made up a program. So you design your program on what you thought the key procedures were. This isn't going to make much sense really if you haven't done it that way, because we've already been doing object-oriented programming the whole time. Today, the most popular programming technique is object-oriented programming. With OOP, instead of thinking first about the procedures, you think about the things in your problem. These things are called objects. Like you might have an object called geometric shape, and you're going to make geometric shape support spheres, and squares and things like that. That's a data, so you're going to make an object out of that data. Or if you're writing a program to keep track of payroll, you might write a person object, that contains information like their first name and their last name, things like that. So we think in terms of data, and then we think data typically are nouns. Here's my person, here's my sphere, here's my printer, And then you think of verbs. What can you do to that data? So an object is a set of data which identifies the current state of the object and a set of, quote, behaviors. Behaviors are the verbs. Those are the methods. The data are the variables that are attached to the object, and then the behaviors are the methods. So employees, you might have an employee object, or a customer object, or a student object. Physical objects, cars in a traffic simulation, aircraft in an air traffic control, electrical components, or mathematical entities, points in a coordinate system. You might need points with an x, y, and a z component, or complex numbers which have a real component and an imaginary component, or time. Benefits of object-oriented programming. Now this is not strictly true, because if you get somebody who's used to doing procedural programming, like COBOL or something like that, this is actually a challenge to leap to an object-oriented programming style. But it's just because they're used to that. But programs are more understandable. Since people tend to think about programs in terms of objects, it's easier for people to understand that. And fewer errors. Since objects provide encapsulation for the data, it's harder for the data to get messed up. So a class is a description of an object. It's the blueprint. So let's define an object. Go ahead and make a new project. We don't need to keep modifying our password class. So make a new project. Who cares what it's called? But now we're going to add a class to our project. So come over here to the project directory of the project you just created. Right-click and do New Java Class. So once you get your project created, click on the package, the directory that contains it. Right-click and do New Java Class. And we're going to make a rectangle class. So that's the name of this object. Now, what does a rectangle have that is really important to us? Well, it depends on what we care about the rectangle. If it was an art program, we might want to know the color of the line drawing it, the color of the fill, how far it's rotated, the length and the width of it, if it's transparent or not. But we're not making an art program. This one's only going to keep track of the width and the height. So let's make two variables. One called width and one called height. That's the data. Now we're going to add the behaviors. And I really dislike that term, behaviors. Methods. We're going to add the methods that act upon that data. We're going to add two methods. A getArea method and a getPerimeter method. So to declare our area and our perimeter methods, we're going to use the public keyword. Eventually we'll be going back and we'll be making our data private. I'm leaving the keywords off here for now, but if you don't say that something is either public or private, it defaults to something being awfully close to public. There are a few more protection levels other than just public and private, but it's almost fair to say that the default state of it is public. So get area and get perimeter both need to return doubles. So public double get area. And we're going to calculate the area. Double A is equal to this dot width times this dot height. Return A. And then public double get perimeter. I'm just going to call it perim. So that's going to be called P for perimeter is equal to 2 times the width, or this dot width, plus 2 times this dot height. Now that's a new keyword that we haven't seen before. Oh, and then return P so that the programmer who called get perimeter can actually make use of it. This keyword right here is optional in many cases. I encourage you to use it though. What it means is that the variable being referenced is a member of this object. And there are times when you need to distinguish whether something is a member variable or whether it's just a local variable. What's the difference between a local variable and a member variable? I could declare another variable up here. Don't type this. Called width. It would conflict with this one. Don't make this change either. If I just did double A is equal to width times height, how does it know which width is it using? Is it using that one or is it using that one? And if you look at the colors, you can get a clue. This one's black, this one's black. So it's actually using that one rather than that one. So this one removes the ambiguity. If you add this keyword, it forces it to look in the class itself for the definition of that variable, and it ignores local variables. All right, now we can use this class. I'm going to go back to my main method, and I'm going to create a rectangle or two. Rectangle R1 is equal to new rectangle. I've created a new object. We've seen this syntax before with that keyword. When did we see that new keyword being used before? Yeah, for creating the scanner. So we've been using the scanner class all along. We've already been doing object-oriented programming. So let's assign the height and the width variables inside that object. R1.height is equal to 10. R1.width is equal to 20. We're making a 10 by 20 rectangle. Now let's get the area and the perimeter. So double area is equal to R1.getArea. And double perimeter is equal to R1.getPerimeter. Then add two print statements to print those out. R1 area equals, plus R1. R1.perimeter is equal to, what am I doing?
Area.
Yeah,
Yeah.
there we go. R1 area is equal to area. R1 perimeter is equal to perimeter. And there we go. The area of a 10 by 20 rectangle is in fact 200. The perimeter, 2 times 10 is 20, plus 2 times 20 is 40. Yeah, so those are right. Why do you care? This seems like a lot of programming to do just to calculate the area and the perimeter. But once you've done that, you can create as many rectangles as you wanted to. You could do this. Rectangle R2 is equal to new rectangle, and you could give it different values. R2D2. R2 dot width is equal to 5. R2 dot height is equal to 5. And you could do the same thing. You could get the area and the perimeter of those, and now you actually have two different sets of data being tracked in the same program. Previously, like if you typed in somebody's name, you could only keep track of one person's name at a time. But now, we can keep track of multiple sets of data just by creating multiple objects. We can create as many rectangles as we needed to. If you were using a drawing program that, drew 20 rectangles on the screen, you would have 20 rectangle objects created. There's something else we're going to do to our function. Has everybody gotten this far? I don't want to rush.
Like me.
Yeah, we're working on this. Rectangle, where did our rectangle class go? It's there, but it's not in the same directory as Java application 10. Where did it go? Let's see, rectangle. Ah, here it is. He's in the Java application 8. So we're going to copy that, paste it in the Java application 10. That fixes those errors. Height. Why is that popping up in IntelliSense? Oh, because let's do that. There. Now it's working.
No
Thanks, sir.
problem.
Cool deal. Got yours working.
Yeah.
Okay, cool. Good to go here. All right. Almost came over here to ask you. Go on. Taking this course. Okay, cool deal. All right, what your homework is going to do be based on this. Pretty darn easy, because it's just going to involve adding one thing to it. I want you to revise this class to contain Z as well as Y. And I shouldn't say revise this class. Let's do this. Make a new class called Cube. Cube has 3 data elements, member variables. It's got height, width, and depth. So instead of get area and get perimeter, we're going to add get surface area and get volume. We shouldn't call it cube, should we? We should call it block. Okay, a new class called block that has height, width, and depth. Instead of get area and get perimeter, it's got get surface area and get volume. I'm going to leave it up to you to do those calculations. Volume is easy though, right? Width times height times depth. The surface area you can also Google up if you can't figure it out. And if you get totally stuck, text me and I'll tell you. So that's your homework. All right. Go ahead and put the the rectangle class that you've done in the same directory as the password one, just so you have it available to you. But I will also copy and paste those into a Word document to make them easy to find. And we'll make this due Monday night. Any questions?